Alright guys, welcome back to our channel. It's Delzy here again. In today's class, we want to look at the limit of a function. Of course, a lot of questions have been asking what are the different approaches one can use to evaluate limits. We have four different approaches here. We have the direct substitution, we have factorization method, we have L'Hopital, we have rationalization. Of course, we have two questions here. So I'll be solving these two questions and I'll be exposing us to the various approaches that one can make use of to solve this. Now let's look at this first question. It said, evaluate the limit of this function as x tends to 3. Please, this is not x equals to 3. As x tends to 3, 3x minus 5 all over 4x squared plus 9. Now, listen up. Anytime you're being given a question to solve, the first approach you have to make use of attempt direct substitution, right? Anyway you see x, insert 3 here, right? If the denominator results to 0, right? Obviously, that is indeterminate. Okay? So let's look at this. I'll say for the a, as x tends to 3, now 3x minus 5, this is divided by 4x squared plus 9. So let's substitute anywhere we see 3. Anywhere we see x, we're going to insert 3. So this becomes 3 into 3 minus 5 divided by 3 squared plus 9. 3 times 3 is 9 minus 5. Now 3 squared is 9. 9 times 4 is 36 plus 9. So this becomes 4 over 45. So class, since the answer to this question did not give rise to 0 or did not give rise to 0 over 0, so this limit is not indeterminate. So this is actually correct. So direct substitution will work for this. This will work for direct substitution. Alright? Now let's look at the second equation here. Now, they say we should evaluate the limit as x tends to 2, x squared minus 4 divided by x minus 2. First, I told us that anytime you have a question like this, insert your value for x and see if it's going to give us 0. So anywhere I see x, I put 2. So this is 2 squared minus 4. This is 2 minus 2. 2 squared is 4 minus 4. This is 2. So this is giving us 0 over 0. So this is indeterminate. So direct substitution is not going to be working out here. So the next thing we're going to do is that since this will not work out for the first one, obviously place these two, obviously is going to give us the same answer. It's either I'm going to factorize, I'm going to expose us to L'Hopital rule. L'Hopital rule is basically differentiate the numerator, differentiate the denominator, and then substitute the value. Okay, so let's rewrite the equation here on the board so that we can look at, we have limits as x tends to 2, x squared minus 4 over x minus 2. Class, remember that direct substitution did not work out here. So therefore, that leaves us with factorization on L'Hopital. So let's use factorization method. Let's use factorization, after which we're going to use L'Hopital. If you look at this numerator looks like difference of 2 squared, right? This is x squared. I can write this numerator as x squared. 4 is same thing as saying 2 squared. So this is x all over 2. Now this is now difference of 2 squared. And difference of 2 squared can be written as x minus 2 into x plus 2 divided by x minus 2. Right? Now, what did I do here? I converted this guy to difference of 2 squared and then actually expanded the bracket. I factorized out. We have x squared minus 2 squared is x minus 2, x plus 2. That is exactly how difference of 2 squared looks like. And if you look at this x minus 2 on the denominator will cross out x minus 2 on the numerator. This leaves us with limits as x tends to 2, x plus 2. So therefore, you now, anywhere you see your x, you now say 2 plus 2, the answer gives us 4. Now this is direct factorization. Now, let's look out and see what L'Hopital rule states regards to this type of limit. Okay, so in L'Hopital said Anytime the limit of a function gives us indeterminate value, what do I mean? After inserting or substituting this value here, you're getting 0. Class, L'Hopital says differentiate both up and down. Now, for me to carry out differentiation, let me give us a quick rule for differentiation. Let's assume this is AXN, where A is the constant, X is the variable, and N is the power. Now, differentiation says that take the power and multiply with the constant. This becomes AX, NA. Now, subtract 1 from the power, N minus 1. Alright? So, we're going to apply that principle here. Now, for this, X squared, there is an invisible one here, but it's not going to be written. That invisible one is this A. So this X squared is going to be 2 times 1 will give us 2x. Subtract 1 from this power, 2 minus 1, so this becomes 2x1. But I'm not going to write the 1. Anytime you differentiate a constant is always going to give us 0. What do I mean? 4 plus 4 is the same thing as saying x raised to the power of 0. Recall that anything that is raised to the power of 0 is 1. So 0 times 4 is 0. So anytime you differentiate a constant is simply values that do not have x. This 4 does not have x. So when you differentiate 4, you have 0. When you differentiate 2, you have 0. Now what if I differentiate x? This is 1 here and this is 1. 1 times 1 is 1. So if I differentiate x, using this ideology, our a here is 1, our a here is 1. 1 times 1 is 1, x. Subtract 1 from the power. 1 minus 1 is 0. Alright? So this becomes, anything raised to the power of 0 is 1. So if you differentiate x, the answer is always going to give you 1. It's a constant value. So here, if you differentiate x, alright, this is going to give us 1. So according to L'Hopital, I'll come here, I'll now say differentiate. So this becomes limit as x tends to 2. Now when you differentiate 2x, you have, when you differentiate x squared, you have 2x. Remember I told us that this 4 is a constant, so it's going to be 0. This is minus 0. If you differentiate x, you're going to have 1. This guy is a constant, so this is minus 0. So this gives us x, 2x over 1. So therefore, I will now substitute my 2 anywhere I see my x. So this now becomes limit as x tends to 2, 2 into 2. Now the answer for this question becomes 4. So therefore, this 4 is the same answer as the one we got for the factorization. So the choice is yours to make. So it's either you go with factorization or you go with L'Hopital. Please subscribe to the channel so that you'll be getting more information, especially when it comes to rationalization. Thank you very much.